Inversion of configuration. Unit 4-4. The 4th of November 2017. SN1 and SN2 reactions. SN1. SN2. Rate. Equals KRX. Equals KRX NOK. Carbocation intermediate. Y. N. Stereochemistry. Mix. Inversion of configuration. Rearrangement. Tilde H, CH3 possible. No rearrangements. Unimportant, but usually weak, better than nucleophile. Unit 4-4. The 4th of November 2017. SN1 and SN2 reactions. SN1. SN2. Substrate. 3 degrees greater than 2 degrees greater than 1 degree. Checks 1 degree greater than 2 degrees. Nucleophile. Unimportant, but usually weak. Strong and unhindered. Leaving group. Excellent. Better than nucleophile. Solvent. Polar and ionizing. Polar aprotic. SN1 and SN2 reactions do not occur with vinyl halides or aryl halides. Unit 4-4. The 4th of November 2017. SN1 and SN2 reactions do not occur with vinyl halides or aryl halides. Consider the carbocation formed for SN1. Consider the backside attack for SN2. Elimination reactions. The substitution reaction mechanisms you have learned are just part of the picture. In the SN1 and SN2 reactions, the species that acts as a nucleophile may also act as a base and abstract proton. This causes the elimination of HX and the formation of an alkene. An elimination reaction can occur along with the substitution reaction. Elimination B is a species acting as a base. Since HX is lost, this particular reaction is called a dehydrohalogenation. E1 reactions. E1 equals elimination, unimolecular. Rate equals K substrate, a first-order process. The rate-limiting step is the formation of the carbocation, the same as for SN1, that's why E1 competes. E1 reaction mechanism. Step 1, the substrate forms a carbocation intermediate, rate-limiting step. Step 2, methanol acts as a base and removes H+. Fast step. E1 reaction profile rate equals KCH33Br, K equals AA. Step 1/RT. Unit 4-4. The 4th of November 2017. E1 reaction profile. Rate equals KCH33Br. EA. Step 1/RT. K equals A. E1 occurs with and competes with SN1. When bromocyclohexane is heated with methanol, two products are possible. Can you draw the mechanism that leads to each product? E1 reactions. E1 reactions are exothermic. E1 reactions occur in at least 2 steps and compete with SN1 reactions. The first step is slow. It is the formation of the carbocation intermediate. The second step is fast. It is the abstraction of H+ from the carbocation by the base. Factors affecting E1 reactions. Structure of the substrate. Can a stable carbocation be formed? Strength of the base. Nature of the leaving group. The solvent in which the reaction is run. Must be able to stabilize the carbocation and the Lg, which is usually an ion. Factors affecting E1 reactions. Structure of the substrate. The most important factor influencing the rate of E1 reactions is the stability of the carbocation formed. Stability of carbocation. 3 degrees greater than 2 degrees greater than 1 degree. Relative rates for E1, 3 degrees greater than 2 degrees 1 degree resonance. Factors affecting E1 reactions, strength of the base. The rate is not much affected by the strength of the base. Weak bases will work. Factors affecting E1 reactions, the leaving group. The Lg should be good. Factors affecting E1 reactions, solvent effects. The solvent must be capable of dissolving both the carbocation and the leaving group. E1 reactions require highly polar solvents that strongly solvate ions. Typical solvents: water, and alcohol, acetone, to help the alkyl halide to dissolve, or mix. Rearrangements in E1 reactions. The carbocation can undergo a structural rearrangement to produce a more stable species. Hydride shift, (H). Methyl shift, (C.H). 3. If ionization would lead to a 1-degree carbocation, look for a rearrangement to occur. Ionization rates can be increased by the addition of reagents such as AgNO3, HAO. However, Ag is not cheap. A hydride shift can occur in either SN1 or E1 reactions. Keo (H). H+. Br. SN1. What would the E1 products be? A methyl shift can occur in either SN1 or E1 reactions. Keo (C.H). 3. H+. SN1. What would the E1 product be? Zaitsev's rule. When 2 or more elimination products are possible, the product with the more substituted double bond will predominate. Zaitsev's rule. When 2 or more elimination products are possible, the product with the more substituted double bond will predominate. Alkyl groups are electron donating and contribute electron density to the pi bond. Bulky groups can be more widely separated.